Greeting everyone, I am Siddha before to explain about my new and last topic in data structures, that is on binary search tree. So binary search tree, mainly the trees are the group of data structures which are of different type and they are used to store data in branches. And now in this experiment we are going to see the working of a binary tree and elucidating its various orders of representing data. So, coming into our experiment, mainly we are defining a structure named tree, in which this tree pointer left int data and tree pointer right are being initialized. Here, the left pointer indicates the left side of the tree, whereas right pointer indicates right side of the tree, and data represents the data or the information stored in them. Pointer of root is the first or the parent element of a tree. Initially it's initialized to null, and star p is also initialized to null. P is known as a factor, the monkey factor, which determines the position to be inserted. So here we are using a function known as void create. So initially we are initializing count to 0. So if while count is less than 7, here there is a while loop, and if the root is equal to null, it means that there isn't any root element present in the tree. Then we have to create a new root. So the root is equal to new tree. So now we'll enter the root node, C in the root of data. This line indicates to enter the initial some value to the root, and the root arrow right is equal to null and left is equal to null, which means only root is created. So now if else p is equal to, if there is a root persisting, so then and we should have to enter the value of a new node. So if this is the value, so if the value is less than the data present in the root node, then and in that we will get two cases, that is if the left side of the root is null, is empty, or else if everything is present. If it is null, then p arrow l is equal to new tree, where it allocates a new space for a new tree, and p is equal to p arrow l, and the allocated data in the p is known as the value which we have given here, and then the left and right sides of the newly constructed node is null. So then the value is entered in left, or else if there is an element present in the to the left of the parent, that is p arrow left is not equal to null, then the element will be placed as usual. So else if the value we entered before is greater than the value present in the root, that is then in that we have two conditions. It will be placed to the right side. If the right side there is an empty node, that is there isn't a node itself, that will create a new node. It will be changed, and the data the value which we have entered before will be stored as a data of this new node, and the left and right pointers are initialized as null. So then the value is entered in right. Else if there isn't if there is a node present in the right, then as usually this will be attached to the new node, and the count increases. So now the in order, pre-order and post order are the main three orders of representing the data stored in the binary tree itself. So if p is not equal to null, so that if the root is not equal to null, then as for in order we'll get the first as LPR, which means L represents left, R represents D represents data, R represents right, LDR. Therefore in order P arrow L, C out P of data, which represents prints the data present in the respective node, and then it moves to right. Whereas in the pre-order, if P is not equal to null, the first data printing takes place, and then the left pointer and then the right pointer occurs. Whereas in the post order, if p is not equal to null, first left movement arrives, then the right movement, and then at last the data is being printed. So in main, after the create function, we could assign the choices in which we want to print, that is in order, transversal, or post or transversal, or pre-order transversal. So therefore for each respective choices, we have in order and a root as an attribute which prints the respective tree in the transversal order. So now this comes to the end of our code, and now we could see our output. So here comes our output. Then we could enter the node value as 4. So if I will enter a value which is less than this one, for example 2, so the value is entered in left, and then if I enter 7, as 7 is bigger, the value is entered in right. So now again I will enter the value 3. Now it's entered in right, and then now I will enter the value as 8. It's entered in right. Now I will enter the value as 1. The value is entered in left. So therefore now again if I enter the value of node, that is 6, will come. So these are the orders, the printing orders. This is a transversal in order, there is a pre-order, and this is a post-order. So here comes to the end of our experiment, and our experiment on the implementation of binary tree is successfully implemented. Thank you.